Roof. Arr! I had to. I'm Dog Bless You. Hi, my name is Charlie, Charles Annenberg Weingarten. It's a real honor to be here at Aspen Ideas. We actually have a booth next door called the Zen Den. In addition to that, I'm the vice president of the Annenberg Foundation, founder of Explore.org, and also the creator of Dog Bless You, if you see that on my hat. So if there's one thing I understand, it's the love of animals, and in today's showcase, the love of dogs, cats, them all. I could go on and on. I have so many dog stories. I've really lived a blessed life with dogs, but today's topic is actually very special to my heart, and I'm very looking forward to sitting down and learning more because, I mean, how many people in this room own a pet, a dog, a cat? Yeah. Okay. How many people in this room have dealt with the incredible hardship of doggy death or pet death? Yeah. I always like to say it is a fastball down the middle. It sucks. You could tell me about the Rainbow Bridge, snore, meant to be, we're going to meet somewhere else. No, it is a fastball down the middle. Because at Dog Bless You, I always say one of the mantras is, animals are the guardian angel of the human spirit, and they truly protect us. So to be so honored to introduce these distinguished people and learn about the idea of longevity in animals and science in animals, I don't know anything about it, so I'm going to be Sesame Street for adults and sit down and learn. And so let's keep it brief. I just wanted to say hello. It's an honor to be here, and I'm introducing Elliot Gerson from the Aspen Institute himself.
Thank you.
I don't know.
Thank you.
Take care.
Thank you, and I hope you can all hear me. That was a wonderful introduction, and we thank you for your contributions to the Institute and to the state of dogs and humans everywhere. Well, I think this is going to be fun and also important, and not just a nice distraction from some of the other topics about the enormous challenges facing the world. But truly important, and I think quite fascinating. I love the title, New Leash on Life, and whoever from the Aspen staff wrote the title and also the sentence about how the keys to longevity for people or for both ends of the leash should win some kind of a writing prize. We have two fascinating people here today and one dog. I'm sorry we did not mic the dog. Maybe we're going to need to make sure we have a microphone because I do think we need to get dogs' perspectives as we go through this. And the topics, longevity and dogs, are extraordinarily important to, and looking at the hands raised, I was going to ask the same question, everyone in this room. Longevity and, of course, its corollary of mortality. And dogs and how valuable and important they are to humans are things that I think all of us can identify with. And I also think the topic is one that's peculiarly appropriate to an Aspen Institute conversation because they're also important moral, philosophical, ethical issues attendant to this, the kind of which that Aspen has looked at in its 75 years. For example, the sociological consequences if dogs like Gus here, start living to say 30 years and therefore outlive many of their owners. What is that going to mean? And also, and the reason I wanted Gus to have a microphone is how do we consider dogs' views as we develop drugs and other things that can expand their life to assure it's something they want and that their lives are in fact going to be richer and not burdened with morbidities of various kinds. And also, as you just heard too, what about any changes in the frankly extraordinary lessons that dogs provide to almost all of us with respect to mortality? I think we all, many of us, probably everyone in this room, remember, the death of a dog as a child, and what that meant to us and what that taught us. And I can tell you that my wife's who's here, and I can also tell you that the death of a dog is in fact vastly more challenging and difficult as an adult than it is as a child. So I think we'll talk about some of those things. And then the other thing I have to think about a little bit about the topic of dogs and maybe with the Institute, I see a number of trustees here, we should think about doing more programs on things like dogs, and especially dogs, because it brings everyone together. Republicans love dogs as much as Democrats love dogs. Maybe not the standard bearers of the parties with respect to loving dogs, but it's true. And maybe we can learn something by bringing people together to discuss things where they truly have love in common and can learn to understand each other more generally. As I said, we have two remarkable people here, and I'll just tell you a little bit about each. Celine Halioua is the founder and CEO of Loyal, which is a biotech startup, which is developing the first drugs that will extend the life of dogs, and also the quality of life of dogs, as you will hear, is very important to her, by targeting the underlying mechanisms of aging, and we'll learn more about that. And she'll share the exciting developments of Loyal, the status of its longevity drugs, and how soon before they'd be available to everyone, all dog lovers everywhere. She's a neuroscientist by training. She now leads a team of neuroscientists, chemists, biologists, and others. And quite remarkably, she founded this company when she was just 24. And they've now raised over $125 million in venture capital, and she'll tell you where they are in that development. Daniel Promislow, coincidentally, is someone I've known for about 30 years, so I have followed his extraordinary career, one of the world's experts in aging generally, and also, of course, specifically as applied to dogs. As a graduate student, he compared the patterns of longevity across different mammals. For example, looking at mice and voles with very short lifespans compared to animals like bats, much longer lifespan, and primates. He then did field work, and one of my favorite examples of that, he did field work in Australia on a species of marsupials, where the males mature at about 11 months, and then, if they're lucky, they mate, and then they die within days. And the females of that species are entirely responsible for raising the next generation of that species. And just as a thought experiment, what if that were true of humans? I think we might have much less violence and divisiveness in the world, but we're not going to talk about that. So, and then of course, he pivoted to dogs after a very important article in Science appeared that showed that the longevity of dogs was associated there was a correlation with a particular gene, and so since then he has been leading really the world's most extraordinary project with extraordinary scientific care on longevity in animals, which he's going to talk more about. So let me jump in, and given the topic, I'm hoping to have plenty of time for questions for all of you. So Celine, let me just start. Why dogs? Why did you focus so early on dogs and become interested in extending the life of these wonderful creatures?
Yeah, so hi guys. I've always been an animal person. I've been vegetarian my entire life. I grew up with 15 cats, 4 dogs, a grackle with a broken ring, a turtle we rescued from the side of the road. I wanted to be a vet for a really long time, but I actually got really passionate about age-related diseases and preventative medicine when I started in undergrad and I started in neuroscience, because a lot of neuro disorders are age-related diseases that increase in likelihood and probability as you get older, and they're also really, really difficult to treat. So I remember I was working in a lab in San Diego that was working on stem cell replacement for Parkinson's disease, so basically trying to graft in new dopaminergic neurons to replace the neurons that degrade and die out in Parkinson's, and it was just such a complex problem, right? You had to, at the time this was embryo derived. They had to, get the right kind of subtype of dopaminergic neuron from the embryo. They had to differentiate it into exactly what they needed. They had to put this very frail patient under anesthesia to try to, put these stem cells in there. And long story short, while the thesis and in some of the cases was actually very successful. It was just so many variables to go wrong and so complicated. I just remember very specifically staring over a thing of a thing of cells and thinking, why aren't we working on preventative medicine? Why aren't we working on reducing the risk of somebody getting diagnosed with this in the first place, instead of waiting decades for them to get diagnosed and then ending up kind of in this arms race that we just are losing over and over again. So to get to your question on why dogs, I was trying to figure out how to work on this for humans, but for reasons that actually don't have to do with the biology at all. It's much more logistical, healthcare system, economics, all these other things that I'm happy to go into if they're interesting. You can't get a drug approved for lifespan extension in humans today, but I had a crazy hypothesis, which was probably fueled by being very naive, that you could do it in dogs. Because dogs, they live a much shorter life. Big dogs live a much, much shorter life than smaller dogs. As the owner of a senior Rottweiler, I'm unfortunately very aware of that. And you can show efficacy in a period of time that's reasonable. And I'm not independently wealthy, and so that was very, very important because I had to raise venture capital to do all of this. We've raised $125 million. We haven't made a dime of revenue besides maybe like the, interest payments due to the high interest rates right now. Basically the thesis is show longevity in dogs, and then you're much more an expert on this, but canine biology is very relevant to human biology too. So what we learn in dogs is not going to be one-to-one to human, but could potentially be much more compelling than, just work in a mouse.
So, Daniel, just one question before we get to dogs strictly. As an expert in aging generally, let me just ask, why do we age? Why, given the power of natural selection, haven't some species adapted to live longer, reproduce longer, and so why?
It's a great
Such
question.
a good question.
And first of all, thank you for the chance to come here and talk about dogs, and all of you for showing up. So why do we age? If natural selection is so powerful, why does everything fall apart? The answer actually goes back about 100 years, and it's a big idea, so it's appropriate for a festival of big ideas. We all inherit new mutations from our parents and grandparents and great-grandparents. And those of you like me who have no mechanical abilities, if you open up the hood of a car and close your eyes and hit the engine with a hammer, it's going to be worse, not better. That's what mutations are like. Most mutations that we get, if they really do bad things, they're not going to be passed on to our kids because we're not going to survive to have kids. But if we have mutations that maybe don't have their effects until we're older, Celine was talking about Parkinson's disease, or think about Huntington disease. Typical Huntington patient, we don't see the effects until we're 50. So all of those mutations that we carry, they have a fuse on them. If it's a really short fuse, it may go off, and most of those mutations go off when we're embryos and we're never even born. As all of you I'm sure know, most pregnancies are terminated before we even know about them. But here's the big idea. Some of those ticking time bombs, those mutations we got from our ancestors, have fuses that are 60, 70, 80 years. There's no selection against them because by the time we have our kids, they haven't gone off yet. We've passed those mutations on to our kids. They carry them. So as we get older, more and more of these tens, hundreds, thousands, tens of thousands of tiny little ticking time bombs inside of us are going off, and there's no selection to get rid of it. If you look at a mortality curve of humans, for most of our lives, it's so low down you can't see it, and then it just takes off exponentially as all those time bombs that have accumulated over evolutionary time go off. And it's true for us, it's true for the fruit flies in my lab that I study, and it's certainly true for the beautiful little dogs like that little guy sitting right there, and all dogs.
Thank you. And I know that there's a lot of wind here, so I'm going to try to speak even louder and ask all of us to do that as well. So Celine, just tell us about Loyal and your developments, and how are these drugs going to work, and how soon are we going to see them so Gus can get one?
Yeah, that's why you invited me here. All makes sense now.
This is a borrowed Gus, by the way. The last time I moderated with a dog on the stage was my own dog named Gus. So, but go ahead.
Oh, interesting. Okay. Yeah, so we started on this big dog short lifespan theory. So this idea that the bigger a dog is, the shorter their lifespan is, and at the extremes, you see a 2x differential. So a Great Dane might live 7 or 8 years, while a Chihuahua might live 17 to 18 years. And for context, it's pretty strange, right, to see a 2x differential in expected lifespan within the same species. I'm relatively short, especially in these shoes. I'm not going to live twice as long as some of the tall people in the audience, right? And long story short, the kind of aha moment for me and the company, or that kind of genesis the company, was that when you look at the genetics of dog size, there's really no one gene that controls a human size, but you can actually sequence a dog and tell within about 10 pounds how big they are. The confidence interval being how much food the dog owner does or does not give the dog, right? And the reason why is there's only about 6 genes that predominantly control dog size, and about 4 of them are in this longevity pathway called growth hormone IGF-1. So it was this kind of intersection point that basically this very well validated, understood longevity pathway where you see the exact same phenotype. So if you make a mouse have really high levels of growth hormone and IGF-1, you get a big mouse that lives a very short period in time. And additionally, the longest lived mouse is a low IGF-1 growth hormone mouse that's very, very small and lives a very long period of time. The exact same thing of what you see with a Chihuahua and a Great Dane. And this was so exciting for me because I've always been a big dog person. It's actually like been a development area for me as a CEO because it's like really bad as a dog CEO to go up to a small dog and then cower because I have like big dog energy apparently. But it was really interesting because it connected it gave traction on an extremely, extremely complex phenotype. Aging is about as complex as it gets. B, it connected something I believe the agency and the general scientific community already understood, which is that dogs have diseases due to historical inbreeding, that we gave dogs genetic mistakes when we turned the wolf into the poodle and into the Chihuahua and into the Great Dane. And German Shepherd's hip dysplasia, Goldens get certain forms of cancer. And this just happened to be another disease, quote unquote, that we gave big dogs when we selectively bred them to be large. And so it connected something the agency and the scientific community already understood with something what I wanted to work on, which is a drug where the only use case is extend the lifespan, primary claim, and the healthspan, secondary claim of the animal. Like that was the goal, to go to your vet and say, I want my dog to live a longer, healthier life. Here you go. This is the drug for that. The dog doesn't have to be diagnosed as anything. It's just an age and weight criteria. And so that was the original inspiration. We now have drugs that are also being developed for senior dog lifespan extension for dogs of most sizes and most breeds. But that was really kind of the foundational work. And I'm happy to dig into any of the stuff that's interesting. To be clear, like I had like the very initial idea, but this has been the work of
just quickly,
a lot of people.
How quickly may we
Okay, I know what you want to get to.
We all want to get it.
Yeah, so I mean, our first drug, if everything stays on track, will hopefully earn FDA approval at the beginning of next year.
Wow.
We last year announced that we earned the first ever, it's called reasonable expectation of efficacy, basically the effectiveness dossier approval for this big dog short lifespan drug. So basically the FDA said, A, they acknowledged that the drug can be approved for lifespan extension, and B, they said that our data supports market approval, conditional market approval for lifespan extension, which as far as I'm aware, we're the first company to achieve that in any species. So a really important milestone for us and us personally in this kind of goal.
That's great. So Daniel, tell us a little bit about the Dog Aging Project, the key learnings so far, and what's next. I mean, it's vast.
Yeah, so thanks for asking. So the Dog Aging Project is a nationwide community science project to study companion dogs, pet dogs, in people's homes, people like you from all across the country, to learn about the environmental factors and the biological factors that shape healthy aging. Why are some dogs healthier agers, longer lived than others? So far, we've enrolled 48,000 dogs from every state in the United States, including Alaska and Hawaii. We are still open for recruitment. If you're interested, dogagingproject.org. All dogs, young, old, male, female, intact, sterilized, mixed breed, purebred. And so we're like, for those of you who know about the human longitudinal studies like the Framingham Heart Study, the Women's Health Initiative, the Harvard Health Studies. We're like Framingham for dogs. We are collecting huge amounts of data from dog owners, and we also collect biospecimens. We do the biology of those biospecimens, blood and hair and urine and all of that. And the goal is to really understand how dogs age. And by following them every year for their entire lives, we then have the power to go back in time and ask about what are the things that we did, to your point, Celine, what did we do that helped prevent disease in some dogs compared to those others that weren't so lucky? We are a lot of things, and I will momentarily get to your question, Elliot, about what we found so far. But I think one of the things that I think a lot about, and that is so true of the discourse that we see here at the Aspen Ideas Festival, the Dog Aging Project is trying to understand aging in dogs, but it's also engaging all the participants. It's about the power of paying attention. That means you watching your dog and sharing what you observe with us. And really importantly, the 48,000 people who have signed up their dogs come from all walks of life. We don't ask who they vote for. We do ask about their annual income. They don't have to share it, but we have rich and poor. We have rural, urban, and suburban. And we surely have Democrats and Republicans and independents. And they all come together over the most important thing about the Dog Aging Project, which is motivated not only by the fact that dogs are the most variable species on the planet after broccoli, maybe, and that they get our diseases and live in our environment and have the sophisticated healthcare system, but people love dogs, and we really need a lavalier for Gus. So just very briefly, what have we learned so far? So far, we've just been analyzing the first year of data. That means just a slice in time. We haven't yet started going back and looking at what did we see 3-4 years ago that's affecting what we see now. We're beginning to do that. Some important things we've learned that aren't surprising: dogs that exercise more tend to be healthier. Dogs that have a healthy body condition tend to be healthier. Like in humans, obesity is a risk factor for all kinds of diseases in dogs. Some interesting things that raise really cool questions, and we are collecting the molecular data to answer why we see what we see. For example, dogs that eat once a day are also dogs that tend not to have GI and pancreas problems. That doesn't mean you should feed your dog once a day. Our late dog, Frisbee, had pancreas problems, and the vet said, don't feed her once a day, feed her multiple times a day. So that might be the correlation. But we're beginning to make all these observations, and with the molecular data, we'll begin to get at the mechanisms for why it is that dogs are short or long-lived. And the last thing I'll say, of those 48,000 dogs, about 1% of our dogs are also enrolled in a clinical trial testing a different class of drugs from the one that Loyal is testing, a drug called rapamycin, which has been shown to extend lifespan in mice and flies and worms in the lab, and which, of course, raises the really important question of when the owners consent to put the dog in a clinical trial for healthy lifespan, what does the dog have to do with it?
Amazing. Celine, Gus, before he left the stage, wanted me to ask you, how do you balance the desire for longer life with assuring a healthy and happy life?
Yeah, so I think it's actually a false dichotomy. I think a lot of people associate working in lifespan extension with extending out that unhealthy last couple of years of life, because that's what a lot of age-related disease therapies unfortunately have to do. Everybody knows someone who's gone through, a really rough chemo treatment, or some of the, Parkinson's and Alzheimer's interventions I was talking about are pretty difficult, and can induce or perpetuate a pretty terrible quality of life. An aging drug doesn't, at least the aging drugs that we're working on, wouldn't work that way at all. The way to think about it is kind of pulling out those healthy middle years. You take an animal that's relatively healthy already, hopefully you see some reversal, really big air quotes, aging is not defined, but improvement in certain known drivers of pathological unhealthy aging. But you also see a retention of the dog in that healthy state longer. So that's actually what we're really looking for in our studies, is looking at, can we perpetuate, basically round out the curve, right? So if this is kind of the quality of life over time of the animal, can we make it more like this, where the dog's healthy, 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 and then whatever takes them out at the end is a relatively fast process, which if and when achieved, especially for humans, will completely change, I think, how we think about aging, right? It's very linked that you get older and you have a worse quality of life, but it doesn't necessarily have to be.
So Daniel, sort of the same kind of question. How do you look at that balance, if there is one, in your own research? And what about the dog's opinions in all of this?
So to the first question, I think one of the great powers of the Dog Aging Project is that we are following these dogs longitudinally. Some enroll young, some enroll old, but we follow all of them for their whole lives. And so because everything happens so much more quickly in dogs, 5 or 10 times more quickly than in humans, we have the opportunity to ask whether the longer-lived dogs are healthier longer, or if they're experiencing longer lifespan with more disease. So that's the first thing. And like Celine, in our own study with rapamycin, we will certainly be asking whether it prolongs healthy lifespan, or what we call Healthspan, which is what we want both for dogs and, of course, for our own loved ones. As for who is asking the dog, it's important to recognize that all the care that we give our companion animals, whether a dog or a cat or a budgie or a turtle, is without their spoken consent. Well, maybe some birds talk, but, and we do it with, ideally, working closely with the veterinarian. We know our beloved companion animals better than anybody else, and we have to make the decision. But keep in mind that we do this all the time as parents when our children, especially when they're prelingual, and then even once they speak. And my own son, when he was a teenager with testosterone poisoning, his frontal cortex was not working very well, not making great decisions. We also have to make careful decisions about the care that we provide, and we ask physicians to provide to our own kids. My wife is a physician scientist, and she enrolls the pediatric patients that she works with in clinical trials to figure out ways to heal them better. So we do that all the time. I'll mention that in the Dog Aging Project, aware of these challenges, we have a team ethicist. So we have about 100 people that run the project. One is a pediatric bioethicist, and then we have a veterinary bioethicist who's independent of the team, because we think it's really important to have constant oversight. But if there's a way to, I have experienced the suffering that my own dog experienced, and even if she lived the same long 16 years that she did, but with less pain and suffering, that surely would have been a good thing.
So, Celine, how do you think the research and work you're doing could be applied to humans, if at all?
Yeah, so I would say there's a direct way and an indirect way. The direct way is, we talked about how, you went into much more detail of how the way a dog ages teaches us a lot about how humans age. They've co-evolved with us. They share an environment with us. They're exposed to the same environmental pollutants. They eat, if they're like my dog, they eat a lot of the similar food as what we eat. And really importantly, they develop age-related diseases over time. The only kind of big variance between what dogs get versus what humans get is dogs don't get cardiovascular disease in the same kind of subtype as what humans get. But otherwise, actually, the incidence rate and prevalence between humans and dogs and age-related diseases is very, very similar. And many of the times, it's random, it's natural, it's due to a lot of what you were talking about. And so if a drug works to extend across, because like, for example, we're also obviously running studies, and we're currently enrolling 1,000 dog pivotal lifespan extension studies that'll be 500 placebo, 500 on our drug, following them for 4 to 6 years. We'll see how the stats work out, hopefully in the lower end, to hopefully show pivotal efficacy for mortality risk reduction. And that's going to be dogs all over the US, dogs of all breeds, mutts and pure breeds and all of that. And that's really important because if an intervention actually shows efficacy in that, again, it's not one-to-one to be relevant to a human, but it's pretty compelling evidence. For context, and you're obviously the scientist here, but when you study many of these age-related diseases in lower organisms, it's often induced. Most mice die of cancer. You don't get as a complex, for example, neurodegenerative disorders naturally in mice as you do in a dog, versus you get canine cognitive dysfunction, one of my favorite indications from a scientific standpoint. And so it's just really compelling that if you can show some movement or some traction on these very complex age-related diseases in these dogs, that maybe you're onto something for humans. That's one. And then two, the reason I think that's actually like a little bit less intuitive is, I don't know if you want to go more into this, but it's just the complexities of developing a drug, especially in the US today. If you're trying to develop a new pharmaceutical for human use, it costs about $1 billion, takes about 7 to 10 years, and you're basically just externalized R&D for big pharma. So the companies that get $100 million, $200 million, $500 million in funding, they're getting it because these usually pretty established biotech VCs are like, oh yeah, I know Pfizer's going to want that, or Moderna is really interested in that. So it's kind of, and of course there are exceptions, right? But generally speaking, this is the pattern you see. And these companies never make revenue. They never bring a product to market before they get bought up by one of these big pharma companies. And that's very effective and efficient in certain ways. But for what we're doing, where A, there's no kind of established market for longevity drugs, and B, it takes such a long time to prove in humans, I think actually having the revenue, which again, hopefully starting next year we'll begin to have revenue, having the team that's focused wholly on lifespan and healthspan extension and no specific indications besides that, and therefore the leverage I'm able to have as a CEO as I run my company will allow us to work on these moonshots in a way that I don't think would fit into the normal kind of biotech economic ecosystem otherwise.
Can I follow up on
yeah,
just
please.
two quick things? First of all, to my world is the biology of aging. Many of us call it geroscience, the study of aging. And one of the big ideas in geroscience is that the single greatest risk factor for all the major killers in humans and in dogs is not smoking, it's not lack of exercise, it's not addiction, it's age. And if you compare the effect of age, it dwarfs all the other factors. And one of the excitements in the geroscience field is that if there are ways to slow down, decrease, attenuate the effect of age on all these diseases, that you get multiple benefits. And even if people aren't living longer, they're living healthier with respect to cardiovascular disease and cancer and neurodegenerative disease. And it's a big idea, and it's not yet proven, but it's an exciting idea. And then the other thing that I want to mention that you touched upon is that dogs are living in our environment, often COVID aside, when we were all working from home, they spend more time in our environment than we do because we leave every day for 8, 10 hours. Dogs are potentially a very powerful sentinel for all the risk factors that we are surrounded by. Think about the volatile organic compounds that are coming off of our carpeting and our furniture because of fire retardants. Think about the microplastics that we're ingesting in our water. We don't know what's going to happen because we live so darn long. 50 years is longer than the lifespan of a graduate student, and we make our graduate students do all the work. Because dogs go from middle age to old age in just 5 years, they have the power to be sentinels, the canaries in the coal mine, for not only the risk factors, but also the good things that will help us live healthy, long lifespans.
That was your group that published that a couple weeks ago. That's a really good paper. You guys should check it out.
So, you just answered the follow-up question I was going to ask you, Daniel, but let me ask a question, sort of a footnote based on what Celine just said, which I hadn't really thought about before. What is the evidence about longevity of, as you put it, mutts versus purebreds, and are there lessons in that?
Are you asking me, or do you want to speak to this?
Well, so of the 48,000 dogs we've enrolled, almost exactly half are male, half are female, half are mutts, and half are purebreds. In general, and this is work we've done over the years, the right dog for each of you is the one you fall in love with. That's all that matters. So I'm not saying you should get this dog or that dog. But on average, for a given size, as Celine so eloquently said, the large breed dogs are shorter lived. For a given size, the purebred dogs are about a year shorter lived than the mutts. Recently, we put out a paper that suggests that the diseases don't differ that much, that whether your dog is purebred or mixed breed, on average, you're going to see the same diseases. Importantly, different breeds are at risk of different things. So there's this gorgeous Cavalier King Charles Spaniel right in front of me. Poor little guys often struggle with heart problems. They don't get cardiovascular disease, but they have heart problems. And it's good to know because we can keep an eye out. Half of all golden retrievers, I am sorry to say, Mr. Annenberg, are going to get cancer in their lifetimes. They may not die of it because there's awesome treatments for cancer, but it's a big risk. So interesting, and probably has something to do with the inbreeding. So that's what we know so far.
Yeah.
Let me ask a different kind of question I alluded to earlier, more of a sociological question. What if your drug is as successful as we all hope it will be, and the kinds of things you're doing, Daniel? What if dogs that are now living to 15 could live to, and I don't know what, we're talking 5 years, 10 years, let's say they could live to 25 or 30 years. What changes are there going to be in human-dog society, community, if you will, if there's not a comparable increase in human longevity? I mean, it just...
The dogs are going to take over. They'll be running the Aspen Institute.
But I mean,
Not a bad thing.
but you understand the question.
Yeah,
I mean,
yeah.
it would really change, I think, so many things. Have you thought about that through? I mean, I mean, I'm not saying good or bad, but there'd be profound changes in how humans deal with their dogs, I think.
Yeah, should I start? Yeah, so first and foremost, I don't think our drug's going to radically extend lifespan in a way that will change things too much. We're kind of, our line we put into sand was 1 year of healthier life. Maybe it'll be more, maybe it'll be less. We don't really know, right? That was kind of the amount that we thought would be, you'd be able to tell from a population standpoint, and that would be clinically meaningful. But yeah, of course, there'll be V2 drugs, V3 drugs, et cetera, and maybe we'll start getting closer to those numbers. I think one of the really interesting biases that people have is anchoring towards whatever we have now as being the right thing and deviation from that being the wrong thing. And so I think if, for example, I'm a horse girl, shocker, right? And horses live to 25 or 30, and that's totally normalized. It's fine. Nobody bats an eye at that. Cats can live to 19 or 20. So I think people really just kind of get used to whatever is normalized in their society, and as things change, they become used to it too. Again, I think it's a long time before we have 30-year-old Great Danes running around. But I think it's a little bit of an interesting thought exercise to go through.
Mm-hmm. Daniel, you have anything?
Yeah, one of the things I really love about the Dog Aging Project, as I alluded to at the beginning, dogs connect all of us. And what we learn about aging in dogs is very likely to teach us a lot about aging in people. I think also it's likely to help us think about the nature of being human. You know, we talk with our veterinarians about end-of-life care all the time. Mm-hmm. We don't like to talk about it in our own lives, but we can learn a lot about how to deal with end-of-life care for ourselves and our loved ones by thinking about it with dogs. Similarly, one of the questions that I'm really interested in thinking about has to do with the fact that many of my colleagues are now saying publicly that they believe that we will figure out how to make people live to 150 or 200 years. Let's say we figure out how to make people live to 121 years, which is the longest known lifespan of anyone, Madame Jeanne Calment. How would that change society? How would it change it in terms of family structure, economics, sociology, all of these things? And so I don't know the answer to your question. I think Celine is the closest of anyone to getting to help us think about that answer if her product is successful. But I also want to encourage all of us to begin asking those questions of ourselves. What would society look like if we suddenly had a pill that we could give a 50-year-old and it would, on average, give them 10 or 15 extra years of lifespan? I would wager that that would dramatically change society. And so we ought to start thinking, encouraged by the work that Loyal and the Dog Aging Project and others are doing with dogs, to think about the societal implications of lifespan extension. There are many trials now in humans looking at age-related disease using the discoveries from geroscience labs. So now is the time to be asking this question. I don't have the answer, but we need to come together in places like this to talk about it.
Celine, a comment, and then we're going to turn it to the audience.
Before the panel, we were talking about this a little bit and joking about the effect on society of a 150-year-old Musk. So there,
and the context of that, which was a question I would have asked, which is, what if that pill to allow someone to live to 150 or 200 costs $100 million? And what are the implications for society if we allow that to happen?
Yeah, I mean, so a quick aside on that, one of the things I really love about working on dogs, so my other life besides aging and dogs and horses and stuff, was actually health economics, and specifically the economics of preventative medicine. We didn't have really good access to healthcare. My parents are both not American citizens, and this was before there was a lot of kind of the broad insurance support for lower income. And so I was like really, really aware from a young age that healthcare costs a lot of money, and that the incentives are not very aligned between you and the healthcare provider, especially if you're on like a really crappy bare minimum healthcare plan or none at all. And one of the things I love about dogs is that the incentives are 100% aligned. You care about your dog today, and you care about your dog 10 years from now. There's barely any insurance. That's like 1% of US dogs are insured. So it's all cash pay, which means you have to really think about COGS. We optimize our manufacturing costs so much to make sure our drug will be accessible and affordable to the majority of Americans. It's the thing I get the most crap from my VCs about, but it's really, really important to me personally. But it also works out because the dog owner is totally incentivized to invest that money to help their dog live a longer, healthier life, because they're on the hook if and when their dog gets sick or gets cancer. And so I love that incentive alignment you get there, and I hope that will hopefully, I think we're starting to see the beginnings of that with some of the consumerization of human pharma. We're seeing it with like the GLPs and this direct selling of drugs where there's a lot of debate there, but if you can align the incentives better within the system that we have, which is not going to change anytime soon, I don't think, you can really start optimizing for more preventative care, which is much more effective, much more efficient. And also the second thing I was going to say, my hot take is that actually longevity drugs are one of the best things we could do for socioeconomic mobility. Again, thankfully my parents are healthy. If my parents hadn't been healthy, I wouldn't be sitting on this stage, because I wouldn't have been able to go to school and focus on that. I wouldn't have been able to go across the pond and go do a PhD over there. I wouldn't have been able to make some bet and move to Silicon Valley and work for free and 24/7, right? Because I would have been having to take care of them because they wouldn't have had coverage. So parents who live a longer, healthier life, that gives their children more mobility. And yeah, you're going to have these fringe negative effects on the tail end of the spectrum, but I think the vast majority of people need better preventative care, and I think that's the type of aging drugs we're working on have an opportunity of delivering that.
Okay, to the audience, saw lots of hands earlier, and I think we have microphones. There's one right in front of you, and then we'll go over to this side.
Hi. With the advent of all the fresh dog food and the intense amount of advertising, how much of a difference does that make compared to prescription kibble from your vet?
I don't think anybody's run that study. But you will note that interrupt me if I'm wrong, but they do all advertise around helping your dog live a longer, healthier life. I think Farmer's Dog literally has long-lived dogs on their box. Do you have anything?
Well, we are collecting that data every year from all of the participants, and a few years from now, we'll be able to look back and tell you about which dogs live longer depending on the food. There are certain prescription foods that are absolutely necessary for certain dogs, and the most important thing there that you can do is ask your vet if there's a particular illness that the dog has that it can't handle standard foods.
Over here, actually in the front row, Ken.
The dog food cabal is going to come after you for that.
Ken Davis, given the mechanism of action of your drug, you're going to include small dogs in the trial, and do you think it's going to work for small dogs? And if it does, how much would you hope it would work for?
Yeah, sorry for not being clear. So we actually have two mechanisms of action. We started with the big dog short lifespan, which is around this growth hormone IGF-1 axis. But you're right, that's very specific to large and giant breed dogs. Maybe there'd be efficacy in smaller dogs, but we're not running that study. The other drug we're working on is actually a different explicit mechanism, but kind of similar broad mechanism to what they're working on in rapamycin around metabolic fitness improvement, which is much more broad. It's applicable to, as far as we know, basically every organism that if you improve metabolic health and fitness, you hopefully will extend lifespan too. And so that's the product we're working on for dogs of all sizes.
And that's the first one going into clinical trials?
It's in clinical trials right now, and it'll hopefully be approved, fingers crossed, next year. Lots of work to do.
Bonnie, and then the gentleman right in front of you.
Oh, I've read, and I'm not remembering exactly, like in Scientific News or just something like that, that different animals, different species have different heartbeats, different number of heartbeats, different speed of heartbeats. Animals with, if I'm remembering it right, slower heartbeats live longer. If I've got that right, faster heartbeats typically are smaller animals and they don't live as long. Well, anyway, how does this relate? Do dogs all have similar heartbeats? They have similar speed of heartbeats?
So one thing I could tell you, across species of mammals, on average, whether you're talking about a mouse or an elephant, they roughly have the same number of heartbeats in a lifetime. Mice very quick, elephants very slow. However, it turns out that that doesn't determine lifespan, and it's important to recognize that bats, for example, have a slower metabolism and are quite long-lived. Birds, for their size, have very high metabolism and are very long-lived, so it's not so simple. As for dogs, I'm not sure about heart rate. It's a good question, and one that I now want to go off and look at
Put
the
some
data.
HRVs on some dogs.
And then this gentleman right here.
Yeah, are there other ethical considerations you think about? Like, for example, could unscrupulous dog breeders use this drug to extend the life of their breeding stock beyond what is healthy? Or for that matter, thoroughbred racehorse breeders do that?
Well, we actually would technically have a label exclusion for breeding dogs, although I don't know if that would stop the unscrupulous type. No, I mean, I think if it works, it should work by the Healthspan first, and then that follows on the lifespan. So you could argue about the knock-on effect of a dog in a less optimal environment, but hopefully there's not going to be a ton of interaction between an unethical dog owner and somebody who's willing to pay for a longevity drug for their dog. Horses is also interesting. There's only 10 drugs approved for horses. FDA-approved drugs for horses, fun fact.
Can I make a quick comment?
Sure, and then the microphone to him, and then we'll go back here.
I just want to come back to this whole conversation of funding for aging, and Celine has done extraordinarily well, and I congratulate you. I said earlier that aging is the single greatest risk factor for all the major killers in human populations, certainly after the age of 50. Of course, we have major challenges in early adulthood. Interestingly, if you look at the National Institutes of Health, all the different institutes that are targeted at cardiovascular disease, cancer, kidney disease, and so on, one of the least funded institutes is the National Institute on Aging. And that's certainly something, those of you who read about us in the New York Times in January might have seen that we've run into challenges with funding from NIH. We actually created the Dog Aging Institute to try and fund our work. So, but in general, I think it's important to keep in mind that aging has such a dramatic impact on our health and our experience, and yet Congress gives a small slice of the budget to the National Institute on Aging. And I don't work for the NIA, but I think that's something that has to change. Any of you who have any power over these things.
Yeah, I agree.
Right here, please.
Thank you. If it's a useful question, could you say a little bit about the technology environment in which you guys are pursuing this knowledge and these advancements? And I'm thinking about things like the validations around the mRNA tools for vaccines, the gene editing tools, machine learning tools, just in no detail, but is this a miraculous time to be doing the work, or is that just all background noise?
Yeah, so I actually came out of a gene therapy lab at Oxford, and so it was like hammer and nail, right? I was like, oh, I'm gonna develop a gene therapy to extend dog lifespan. And it actually ended up not being the right way to go about it because of actually the COGS bit that we were talking about, and actually also safety. So we haven't really talked about this, but I know both of us have very aligned views in this, that if you're going to give a relatively healthy animal a drug to extend their lifespan and keep them healthy longer, it better be damn safe, right? There's no tolerance for side effects or adverse events. And so actually one of our philosophies now is to be radically boring. Like basically the only thing we like innovate on or like spicy on is this idea of a drug to extend lifespan. Now some of our distribution strategies are a little spicy too. But everything else is like super safe, super long-term data, super validated mechanisms, and we thought that was really important for a V1. That's why I was saying earlier, I don't think we're enough 30-year-old dogs, because we didn't optimize for efficacy at all. We optimized it for sufficient efficacy and as minimal a downside as possible with the data we have.
And one follow-up that is related to that. I think this is actually the most exciting time in the history of our species to be doing science about human health and dog health. And the new tools that we have not only enable us to develop things like mRNA vaccines, but also to understand with a real kind of depth just how every single one of us is like each other and different. So we have a paper that we're about to submit studying a drug in fruit flies that makes them live longer, showing that across 200 different genotypes, they all respond very differently, and we now have the tools to begin to understand why. In humans, we call it precision medicine, so we can think about precision veterinary medicine to understand what's the right dose and right drug, and it might be that Loyal is going to discover that for some dogs, this is the maximum appropriate dose and the right drug, and for other dogs, maybe it's a different drug altogether, and we are only able to do that now in the last decade because of all of these tremendous molecular advances that allow us to understand the uniqueness of every individual.
Well, I'm sad to say our time is up. We could go on all afternoon. I'd just like, again, to thank our guests, Celine and Daniel.